Welcome back. Today we're going to be looking at randomness in Python. And Python can't really generate random numbers, like when you roll a die or toss a coin. But what it can do is generate pseudo-random numbers. And this means it's based on some sort of information, so it's not entirely random, but you'd never be able to guess what the number was, and it wouldn't be predictable. So the module you use is random, and obviously the first thing you've got to do is import random. So I'll do that. And then when you've got that, the first function that they advertise is random.random, which is kind of their main function as it's named after the module. So if we run that, we get this value. And that's because the random.random function generates a random number between 0 and 1. So we could run it again, and this time we get a different one. And we could keep doing this and they'd probably be different every time. But you can also see how many decimal places it's giving us, so that you never get two numbers that are identical. But it also has some modules which work with integers. So the first one is random.randrange stop. So you put in where you want it to stop, and it will generate a random number between 0 and stop -1. And this will be an integer. So if we do random.rand range, and it's telling us all these values, but we'll come to that later, and we'll pick 10. We expect a random number less than 10, and it's giving us 6. Do it again, and this time we'll expect a different number. But here it is possible to get the same number twice because it's random. Then you have random.randint, which generates a random number between a and b. However, this time it can include a and b. So if we do generate a random integer between 1 and 10, this time we could get 1 and we could get 10, and we get 5. Then, moving on from that, you've got random.randrange start and stop, but you can also have a step function. And you'll start to notice that this randrange function looks a lot like the range function, and that's because that's what it's based on. So random.randrange, and we can see that automatically the step is equal to 1. So this time we'll start at 5, go up to 15, and have a step of 2. So we know that our number is going to be odd, and unsurprisingly it is. There are some more functions they have that work with lists. So one is random.choice, and you put in a sequence and it randomly picks something. So if we generate a list, let's go A, B, C, D, and I'll stop there. And then we use that list again. We can do a random.choice, put that list in, and this time it gave us back C. And one thing you might notice if we do random.choice, and instead of using a list, use a range object, and we pick 10, this is exactly the same as doing random.randrange 10. But actually, when they do it, they don't run it like this. They have a slightly more efficient process. And in the same way, random.randrange with multiple values is the same as having different ways of using the range along with random.choice. You can also do random.shuffle. So if you have a list or some sort of sequence and you want to shuffle it, then you can do that. And an X is just a random number, but that's not really necessary because they generate one for you. So if we then take that list and we shuffle it, what it's done is it's shuffled the list itself. So it's not really clear to see. If we say that list is equal to that, and it's bad practice to name variables using restricted words, but we'll do it, won't break our function. And then we shuffle our list, and then view the list. We see that that's been shuffled, and that's why there was no output previously. If you shuffle, for example, a tuple, which is immutable and you can't change, there are other methods you can use. And then you've got distributions, and these are really useful for data analysis rather than everyday programs you might write. And Python is very good at data analysis, which is why they have all these methods. And there are lots of distributions that you can generate. So the first one's a uniform distribution, which is uniform as it says. You've got a Gaussian distribution, an exponential distribution, a gamma distribution, a beta distribution, a log normal distribution, a normal distribution, a von Mises distribution, a Pareto distribution, and a Weibull distribution. And one thing you could use this for is to create a guess my number game, although maybe you want to do it kind of the opposite way to we did it, where you have to guess the number the computer has rather than the computer guessing your number. Hopefully you've enjoyed this function. If you ever need something random, you know where to look. See you again, same time next week.